Hi everyone, it's so nice to be here. I'm just so honored to be an MLK Fellow. It's been a wonderful year, and I'm so glad to be able to talk to you today about my work and what I've been doing here as a fellow. So my name is Dr. Lola Fatoyinbo, and I'm hosted here by Professor Daniel Wood in the Space Enabled Lab. Quick overview of my presentation. I'll give a little introduction about who I am, the inspiration that I had for becoming a scientist and also for applying to the MLK Scholars Program, my approach, what I've been doing in terms of mentoring, the courses I've been teaching, and then hopefully get some questions from you. So a very quick introduction to who I am. My home institution when I applied for the fellowship was NASA's Goddard Space Flight Center. But in August of 2025, I ended my career as a civil servant with 6,000 other civil servants, part of the NASA Corps. I'm also a National Geographic Explorer, meaning that I have a grant. I have several grants from the National Geographic Society, and I'm part of their larger group of explorers. My sponsor here is Professor Daniel Wood from the Space Enabled Research Lab. In the Media Lab, Danielle and I have been friends and colleagues for a very long time now. We've been working together on several projects, both when I was at NASA and Danielle was also still at NASA, and since she's become a professor here at MIT. And it's such a pleasure to be in the Space Enabled Lab. I have some pictures here. The first two pictures they're on your left are actually on my last day at NASA Goddard. I used to run my own lab there. I had a team of students and postdocs and interns who I worked with, and I'm still working with them. They're still at NASA Goddard. And I'm so glad that I had this fellowship to fall back on because it has really been a lifesaver. So thank you. As mentioned earlier, my areas of focus are in the ecology, environmental sciences, earth science, aerospace, and aeronautics. So I call myself a space ecologist. And my inspiration for this field and for really all of the work that I have been doing really came from encountering this image. I was a graduate student, and I walked to my professor's office, and he had a huge poster of this printed outside of his office. This was before we had Google Maps, before we had even seen, most people had seen satellite imagery. I had never seen a satellite image in my life. And I was just really stunned by seeing it printed out. Because at the time, we really had only been looking at maps. And this is a view that I had only had the pleasure of seeing when I was sitting in an airplane and looking outside of the window. So I asked him, my gosh, what is this? He said, oh, this is a satellite image. It's provided by NASA. In fact, it's multiple images that are stitched together in what we call a mosaic. And this is from an instrument called MODIS that is a NASA instrument, and all of this data is available for free. And I was just shook because I thought this was beautiful. And I also realized that with this type of data, I could explore the entire planet, especially areas that were really hard to access, places that maybe were not safe to access. And I could also recognize some really iconic landscapes like the Okavango Delta, which is in Botswana in southern Africa, right here. Of course, the Sahara Desert, the Congo Basin rainforest, and then also my home country of Nigeria, which at the time was a place where I really wanted to work, but was not necessarily a place that was safe to access. So I thought with this, I can explore anywhere, and I can go to all these places that are not accessible to me at this time. I also thought that this would be a really powerful tool to really be able to do science and to complete data gaps that we had all over the world, especially for areas that maybe did not have all of the resources and all the investment in scientific research or access to that type of data. So really the feeling that I had when I was looking at this was, first of all, a feeling of awe, but also of responsibility, because I was feeling like if we can see the planet at the scale, we can also measure how it's changing, who's being affected, and what needs protection. So I was having my very own overview effect. This is a feeling that astronauts have when they go into space. And they look down at our home planet and they just feel awe, and they have this feeling of needing to protect our planet, even though they are up in space. I, however, never really imagined that one day I would be working at NASA. I had not spent much time thinking about NASA, to be honest, or space. I was very much a forest ecologist and environmental scientist. To me, NASA meant astronauts, and I thought they were cool, but I didn't really know what it was that they did. Now, I work with this type of imagery all the time, and my focus is really on forests. I map forests all over the world, especially coastal ecosystems, coastal forests, and mangrove forests. And my focus is on trying to estimate how much carbon they store. And I'm really interested in carbon because, of course, this is a really vital component of our atmospheric composition. But forests play a huge role in how much carbon is in the atmosphere, because they actually, when they go through photosynthesis, we always learn about trees producing oxygen, but they're also, of course, absorbing carbon and using that carbon to make wood. So all wood is actually 50% carbon. And as we cut trees or forests are burned, all of that carbon is going back into the atmosphere. But this is actually a natural cycle that occurs. Trees are growing, they absorb the carbon, and then when they die or senesce, especially in the winter months, a lot of that carbon gets emitted back in the atmosphere. And in fact, the effect that this has on global carbon concentrations is so great that you can actually measure it from space. So this is an animation of global carbon dioxide concentrations over a full year in the Earth's atmosphere. This is based on actual data that was collected by NASA instruments and then modeled at NASA. And everything that's in orange here is carbon dioxide concentrations. And I think what's really interesting when you look at this animation is that, first of all, carbon dioxide is not uniform across our planet and across our atmosphere. It's moving all the time. And you'll see as we go into the northern hemisphere spring and summer months, that concentration of carbon dioxide is actually going to decrease. You can also tell that most of the carbon dioxide is in the northern hemisphere, and this is because most of the land masses are in the northern hemisphere. Most of the people live in the northern hemisphere. And those areas that have the highest emissions, especially from fossil fuels, are also in the northern hemisphere. But you can also see things like fires. So if you're looking over Central Africa, you can see large fires coming over Angola and the Congo. This is in their winter months and our summer months. And as we fly over and get to the east coast of the US, you'll see a similar pattern. You see in these summer months, even though we've absorbed large amounts of carbon dioxide, you can see areas where you have forest fires that are point emitters, and same in the Brazilian Amazon. So my focus is really on these mangrove ecosystems. And mangroves are trees that grow in tropical and subtropical areas worldwide. And they grow in the area where land meets sea. So they're salt tolerant. And they're really important for many reasons. They provide habitat for both terrestrial and aquatic species. They store really, really large amounts of carbon. And they also protect the coast from energy that might come from the ocean inland or from upstream down. In many ways, we call them climate superheroes because not only do they store large amounts of carbon, but they also protect us from the effects of climate change, like hurricanes and sea level rise, tidal waves. But as climate change has been advancing, these trees that have historically been really able to protect us and keep up with climate change are actually also getting hit quite hard. This is an example of an airborne image from the Florida Everglades that was taken in I think this is March of 2020. and then December of 2020. So this is before and after Hurricane Irma. This resulted in the largest die-off of mangrove forests that was recorded at the time, over 10,000 hectares. And using satellite imagery and models in our science, we were able to actually predict the areas where this die-off would happen and why, and hopefully use that information to, we were working with the Park Service to give them information as to how they could use this data to mitigate the effects of the hurricane and the storm surge. Working in a mangrove is also not easy. The same things that make them so amazing in terms of coastal protection are also the same things that make them really, really horrible to work in. You see me here, sometimes you have to climb over the roots, sometimes you have to climb under the roots, and sometimes, in this case, we had to climb over to get under the roots. It's really exhausting, and it's very inaccessible and hard. In this case, we were trying to get soil samples so that we could estimate and see whether these mangroves would be able to keep up with sea level rise. It's also very muddy. I like to share this video. This is from a field campaign we had almost 10 years ago now, where we're collecting both airborne and field data. And this poor postdoc is a radar engineer. This is his first time in the field, and he went to one of the most difficult field experiences that you could have. It's really tough. And it's not always safe because, yes, there's all that biodiversity that looks great on a screen, but when you're actually face-to-face with it, it's not that great. So this is why I love doing remote sensing and working with satellite imagery. It's nice to be in the field a little bit, but not all the time. So my specialty is really in combining multiple data sets. I work with optical data, radar data, LiDAR, and different maps to, on the one hand, to produce these maps, but also to develop new algorithms to help us analyze all this data and get some information out of it that is useful. And really, my focus has been on working with active sensors. So these are radar and LiDAR sensors that will be shooting either laser pulses or microwaves from the spacecraft or the aircraft down to the ground. And by measuring the time that it takes to get from the instrument to the ground and back, we can estimate how high the ground is, but we can also get an understanding of how tall the canopy is. And when we're working in forests and we know how tall a tree is, this gives us an understanding of how much carbon is actually stored in that forest. So the very first time that I did this was using data from the Shuttle Radar Topography mission. This flew a very long time ago now, back in 2001, and when we started working with this data, it was really a revolutionary data set. This was the first time that we measured the elevation of the planet of Earth on a global scale. This was collected in 2011 from a space shuttle, and I finally understood what it was that astronauts do when they go to space. This really helped me. This was a really important data set in terms of the data that was actually collected, but also as a demonstration of the technology. And we use this data to actually produce many maps, especially of mangrove forests, of their height and their biomass and their carbon stocks. And using this map, we're actually able to find the area with the tallest mangrove trees in the world, which is in Central Africa, where these trees are, where we had mangrove trees that were over 65 meters tall, which is 215 feet. So if any of you have ever been to Florida or have ever seen a mangrove, it's probably not that tall. It was probably maybe 10 feet tall, 20, 30 feet tall. These were 15 times taller than the global average. And there is no way that we would have found them if we hadn't had this data set and this map. So this is one of the applications for ecology that was really important, but actually the processing techniques that were developed to make this data set allowed me to also work with engineers and work on new instruments. So I spent a lot of time working on this digital beamforming radar platforms. We worked on an L-band concept and a P-band concept. And this digital beamforming radar technology essentially is different from your conventional radar because it allows you to image multiple places at the same time or to move the area that you're imaging from your sensor on both sides of your aircraft or spacecraft. In fact, so on the left here is one is a spaceborne concept called DBSAR-2, but we also had an airborne concept called EcoSAR that I helped develop. This is a P-band airborne system that flies. There's two antennas that fly underneath in this case it was a P-3 plane, which is a former bomber plane, but it essentially flies on a really large plane, and by having the two instruments, we can image the same area on the ground and get the height of the area. These antennas are now here at MIT. I'm so glad that I was able to bring them here. Last summer, NASA was trying to access them as part of the overall efforts to save money, and we're going to access this instrument that was was part of a $4.5 million effort, and still a really, I think, groundbreaking technology. And I'm so glad that I was able to bring it here. It's now in storage here at MIT, and I really look forward to being able to hopefully work with it in the future. So the whole system is transceivers, so that's, I'm sure people here know better than me. The processing computer, the antennas, and then all the rails that the data goes on. I also had the pleasure, and thanks to my experience, I was able to work on an instrument that is now on the International Space Station. It's called JEDI, or Global Ecosystem Dynamics Investigation. It's an instrument that's on the International Space Station, on the Japanese external module here. This video is going to zoom in on it. It's a LiDAR instrument. It was the first LiDAR developed that was specifically to measure vegetation structure. It has 8 beams that are shooting out of the bottom of it and collects these samples everywhere in areas between 50 degrees north and south. And one of the beauties of the JEDI data and of LiDAR data is for one, the accuracy at which it measures the elevation and the height, but also with this data, we can actually measure not only the height of the top of the canopy, but we can also get an understanding of what's happening below the canopy or in between the top and the bottom. What inspired me after doing all this work to apply for this program? There are many things that really did inspire me to come here. You know, I've been working with Danielle for a long time and have been hoping to be able to do this, to continue doing this. But one of the things that happened as I was doing my research is that oftentimes I was feeling like, in some ways, I kept seeing our planet dying, and I kept describing the death of our planet. I have a colleague who says that he was tired of writing the obituary of our planet and wanted to actually do something about it. At the same time, it's not all and always sad. In fact, I think that one of the main things that I always see when looking at this data is how beautiful our planet actually is. I spend a lot of time looking at satellite imagery, I look at animations, I look at data, and I still feel that feeling of awe when I'm looking at this data. And I really feel like there's a disconnect between what we do as scientists and what the general public or our leaders know. In fact, still to this day, people are surprised when I tell them that I'm an earth scientist who worked at NASA, right? So it was really, I've really been thinking about this for a while, and what better place to be able to think about this and to communicate your science than at a university, and especially at a university like MIT. So really some of the challenges or ideas that I've been thinking about or wanted to address was how can I use space as a way to help protect our planet? And is there a way to use this space technology to get people to care about our planet and protecting it? And of course, there's no better lab to do this than the Space Enabled Lab here at MIT that Dr. Wood leads, which is our home for sustainability and space technology applications research. I've had the pleasure of being able to co-teach with Danielle, and really, I feel like we are reshaping how people think of applications of space technologies and how these are taught. Of course, there's the wonderful interactions that you get to have with students, both in terms of me teaching them, but also learning from them and what their interests are, and with faculty. And really, I think one of the big advantages and one of the things that I've been able to do is really just to have time to think and time to focus on the type of work that I want to be doing that combines exploration, conservation, and storytelling from this unique standpoint of space. Some of the questions I've been wondering about is how can I use space as a way to protect our planet? How can we make this data more accessible and understandable and actionable? And is this a way to get people to care about Earth? So really my approach here has been focused on my research, on teaching and training, and then also on science communication and storytelling. From a research perspective, I've been continuing to work on mangrove forests and on tropical forests with a focus on Africa. Recently completed a study on mangrove loss in the Niger Delta in Nigeria, here combining 40 years of satellite data, radar and LiDAR data, and citizen science and oil company reports of oil spills that have been happening in this region for over 50 years. This is a study that is now in review in Transactions of the Royal Society B. And I think it's going to be one of the first studies that really takes a look at the changes that are happening there and trying to address what the different drivers are, trying to explain why are we seeing all of these changes that are happening in Nigeria, which has one of the largest mangrove forests in the world, but is an area where these forests are not protected, and where we're seeing a global trend of a decrease of loss of mangrove forests everywhere except for Nigeria. And one of the goals of this was also to raise attention and try to explain maybe in ways that policymakers understand why these areas are important. So one of the results and one of the calculations that I did was to try to understand how much is lost in terms of ecosystem services. What's the dollar sign that you can put in terms of the services that these ecosystems provide to kind of raise awareness for policymakers? And what I found was that Nigeria, if this continues, is losing about $1 billion a year in terms of ecosystem services that they're getting from these mangrove forests and these areas, based on the carbon price, but also based on other ecosystem services like coastal protection and fisheries. Just very recently, I found out that I was selected on a team that I've been on this team writing a proposal to develop a new instrument called EDGE, which is the Earth Dynamics Geodetic Explorer. It's essentially the follow-on mission to the JEDI instrument that I showed you earlier. And maybe just a month ago, after over 3 years of writing this proposal, we found out that this mission has been selected as part of 2 Earth System Explorer missions. And we're very, very glad. This is a mission that will be the first global satellite imaging laser altimeter. So it will be essentially imaging LiDAR, not just a sampling LiDAR, for both applications in glaciology and ice and cryospheric sciences, and also vegetation. This will be launched no earlier than 2030. But of course, the work to get this instrument built and launched starts essentially this year. I've also been teaching this very wonderful class with Dr. Wood entitled Can Space Enable Designs Advance Justice and Development? That was a class that we co-taught last semester. This semester we're teaching a class called Space Enabled Designs for the Development Leader. It's been really, really enlightening and wonderful to be able to interact with the students and to teach. I have not had the opportunity to teach much more than workshops, which are usually to either non-specialists or people who are already specialists in remote sensing. And it's just really, I found it very helpful to be able to teach to a group of students that come from so many different backgrounds. It's really helped me kind of target my message or make my message stronger, and of course my teaching skills. And then finally, I also had the advantage of being able to participate in a set of expeditions that are funded by National Geographic. These are called the Perpetual Planet expeditions. I was on the Atlantic Ocean one in the Gambia, which is a mission where we were on the sailboat going up and down the coast of the Gambia and also into the Gambia River, collecting data on water quality, bathymetry, different ocean measurements, but also working in the mangroves and with a whole set of students from the Gambia and also from the US who came to the Gambia and are part of this expedition. This is really one of those projects where that combines all of my interests from exploration to conservation, science, and scientific measurements. We're also working with satellite imagery, but also storytelling, because we're hoping that there will be a documentary coming out on this work. By being here, it has also allowed me to get recognition from different entities that I would not have been able to be working with previously. So just a couple of months ago, I was recognized as one of the Explorers Club's 50 people to watch that are changing the world. Thank you. Or rather, 50 people changing the world that the world needs to know about. And really being here at MIT allowed me, for one, to be able to apply to this, but also to get this recognition and to be able to be part of the Explorers Club, which I don't know whether I would have been able to do before. So what is my intended impact? And I think I have here two pictures that I like to use as examples. On the left, I'm showing one of my students and interns, Liza Goldberg, who started working with me when she was a 14-year-old student and is now in her PhD program. But Liza really is one of the reasons why I feel like the satellite imagery is so powerful and can have such a big effect on people's impressions and the way people see our planet. Liza started as an intern, and when she first saw satellite imagery, she had a really similar reaction to what I have. And she was at the time a middle school student, very quickly became a high school student, and developed her own course and project to train her fellow high school students in how to work with satellite imagery. She has now been doing this course for many years, and it's a program that has really exploded to the point where she has trained, I think, over 18,000 people around the world. And I think that is kind of what I'm hoping might happen here, where by being able to speak with students, young people who have ideas that I could never even come up with, that they are able to take this technology and their knowledge and whatever it is that I can share with them and make something bigger out of it. And then my impact outside of MIT, this is a picture of my son actually coming home and showing me a video that NASA had made, stitching work, an interview that I had made and overlaying it with work from the Jane Goodall Institute that they had showed at his school. I had no idea that this video existed. And he came home, of course, was very proud that he got to see his mom on a video at school. But I think, again, this is, once again, an example that highlights the impact that this type of storytelling that our work can have and the impressions that it can leave on the next generation. And also, I could have put my mom or my neighbor in this picture just as well, where I think it's really important for us to communicate our science if we want to really have a broad impact. And then finally, since I've been here, being here and having this fellowship has really allowed me to work on new projects too. So I'm working on a new documentary podcast project. It's entitled The Human Element, where we're looking at the science, the technology, culture, history, and philosophy, and also the controversies that are surrounding the question of how do we protect a place. And we're hoping that the upcoming seasons will focus on the Niger River, and endangered waterways in New Mexico's historic pueblos. So moving on to some community interests. One question that was here in the slides was my philosophy on mentorship. And I think, like I explained in previous slides, really what I'm hoping to do is to use my experience and my knowledge and also the network that I've been able to build to support students and faculty, inspire, and really be in service of their growth. And so with Professor Wood, we've been working on several grant proposals with her and her team, but also with other more early career researchers that are here at MIT. We've been working and advised with students, both graduate and undergraduate, that are in multiple departments, which I think is such a benefit of being able to be here at MIT, that you get such a broad just really a broad group of people, especially in the Media Lab, who are taking our classes. We've been able to meet with and brainstorm ideas with some of our industry partners, which was really helpful. And also I've been able to share some of the external grant opportunities that I know about with people that are here at MIT, both students and faculty. And thinking about what some of the learning outcomes are from the classes that I've co-taught. First of all, my focus really in the class was talking about SAR data, so radar data, LiDAR, really the remote sensing applications and technologies. And the focus was really to teach these students to understand not just how to use the data and what the data is, but also what can be done with it from a real world application. I wanted them to examine gaps in access. Who has access to this data? Who gets to use it? Who knows how to process it? And how does that affect our decisions? And we've also been talking about essentially designing with people on the ground, not just for, which is something that Professor Wood, of course, has also been working on very much. Learning about co-design frameworks that include both local and indigenous communities. And then from another community side, I had the pleasure of being able to participate and attend the Zero Robotics competition that happened here at a few months ago, maybe actually a month ago. I will say that might have been one of the highlights of my stay here. It was really, really wonderful to be able to participate and to see this competition. And coming soon, I'm hoping to connect some of my colleagues from National Geographic that are National Geographic explorers. I'm hoping to invite them to come here, give talks, and then connect with the MIT students and faculty. And I will leave it at that for today. Thank you so much.